In this section, we will use some animations to describe certain theoretical principles regarding the flight mechanics of a kite in order to answer some very simple questions. Why does the kite fly? What is the angle of attack? What elements modify the power supplied by the kite? The 3D animations will also help us to understand and visualize the flying space of a kite, often referred to as the wind window. Why does the kite fly? The profile of the kitesurfing kite is strangely similar to the profile of an aeroplane wing. There is a leading edge, the trailing edge and upper surface, called the extrados, and a lower wing surface called the intrados. In this image, we can see that the upper wing surface is longer than the lower wing surface because it is more rounded. In accordance with the laws of physics, the two sections of an airstream separated by the leading edge must meet at the same moment on the trailing edge. Thus, given that the upper surface is longer, the speed of the air over this must be higher than the air going under the wing. Contrary to popular belief, it is the low pressure upwards that represents 70% of the aerodynamic force, while the increase in pressure on the underside of the wing contributes about 30% of the aerodynamic force. The angle of attack. The angle of attack is the angle between the airflow direction and the wing profile or chord. This may be modified by pulling on the bar. The more I pull, the more the angle of attack will increase. When I push the bar, or depower the kite as it is called, the angle of attack is reduced. What changes the traction force of the kite? The power of the kite may increase if the wind rises or if you accelerate the kite in the wind window. A higher angle of attack will also increase the traction. However, if the angle of attack exceeds a certain value, then the turbulence created by the profile will increase and directly reduce the flight ability of the kite. At a certain limit, the power of the kite will be reduced enough to prevent flight. You must remember to push your bar to return to an acceptable angle of attack and to remain in flight. You will lose flight capacity if you pull too hard on your bar. Thus, it is important to adjust the trim according to the wind speed so that you are not suddenly overcome. If you release the bar, the kite power suddenly drops off. The kite will no longer provide traction and will fall gently in the wind window. But what is the wind window? The wind window is the three-dimensional area in which the kite will fly. It is essentially a quarter of a sphere perpendicular to the wind centered on the pilot. Basically, imagine a quarter of an orange. The kite will move around the perimeter or the skin. The size of this quarter sphere is proportional to the length of lines used. From the point of view of the kite surfer, the wind window is a semicircle. We will now describe the different zones of the wind window. The circumference or perimeter of the wind window can be described as a clock face from 9 o'clock to 3 o'clock. When the kite is directly above your head, that is, in the 12 o'clock position, this is called the zenith or the neutral position. The edge of the wind window is the area of lowest power, and the kite flies at the same speed as the wind. We can glide the kite around the circumference of this semicircle and stop at any precise point. Thus we say that the kite is placed on the edge of the wind window at a particular place, for example 1 o'clock, 11 o'clock. Inside the window, there is a zone of low power, one of medium power, a zone of high power, and one of very high power, which is called the heart of the window, simply referred to as the power zone. When crossing these zones, the kite increases its flight speed, providing more and more traction. The traction falls off as the kite approaches the opposite edge of the wind window. The kite must be launched at 9 o'clock or at 3 o'clock. Using an imaginary line from the zenith, the neutral position to the ground, we can cut the wind window in two, obtaining 2 half wind windows. This is an important idea because to go from one side to the other, the kite must be maneuvered in only one of these half wind windows. From 12 o'clock to 3 o'clock to move towards the right, or to make a right-hand side tack, and from 12 o'clock to 9 o'clock to move to the left, or to make a left-hand side tack. For safety reasons, when maneuvering your kite, it is important to ensure that the entire wind window is free of obstacles.